Hello, everybody. Welcome, and thank you so much for joining us. I know this is conference season. I know you all have so much to do, so we're happy to see all your faces. Well, welcome, welcome. And I see some names that I recognize. Hey, everybody. We have a pretty cool presentation today. I'm not going to take too much time away from introducing our hosts and our speakers today, but in case you forgot, I'm Sarah Nuama. I am one of the co-hosts today for our 101 series. We also have Jose, and I'll pass it to Jose. He'll go ahead and introduce what we got going on today.
Hey, thank you, Sarah. Yeah, I mean, I'm excited. It's also the beginning of spring. Everybody's going out, everybody's getting to the conferences, and we're all getting ready to get some more action into the technical world. Hopefully, all of you are as well. So I will do a quick introduction for Brooklyn SolarWorks, and then I'll give a quick introduction to Kate and Sean, which will be provided in the presentation. Um, so Brooklyn SolarWorks was founded in 2015 by three seasoned industry professionals with a shared mission to make solar appealing, accessible, and practical for New York City urban homeowners. For years, most solar contractors relied on methods designed for suburban homes, leaving New York City's unique urban architecture, particularly its dense residential neighborhoods and iconic flat roof townhomes, underserved. While solar adoption surged in nearby New Jersey and Long Island, the industry largely overlooked Brooklyn's potential. Brooklyn SolarWorks changed that by developing solutions tailored to the city's distinct built environment. Well, I mean, I think that is spot on to what we should be doing with huge spans of flat roofs for sure. So much wasted potential there for many cities. Um, but joining us today, we have Kate Eagers. I hope I said it correctly. She's the project manager for specialty projects, managing final designs, permitting, and construction coordination. And we have Sean Velez, who is a project developer for specialty projects, overseeing the early phases of design and project conception. With that, I will cede the floor to Sean and Kate. Take it away.
Hey everyone, thanks Jose. Appreciate that little intro. Very happy to be here with you all discussing the clean energy portion of a passive house design and implementation. And I will share my screen and we can start the presentation off. I'm here with my colleague Kate, like Jose said, who's our project manager on these types of projects.
Hey everyone, thanks so much for having us today. Excited to show you what we do.
So like Jose mentioned, we are a 10-year-old solar design firm, permitting firm, installation firm here in New York City. We were really designed from the ground up to install on specifically New York City buildings. And started with townhouses, started with residential solar, and have grown to install on commercial properties, co-ops, pretty much any type of property that exists within the 5 boroughs. We are now able and very good at installing solar on. And in growing over the past 10 years, we created a small department within Brooklyn SolarWorks called Specialty Projects that Kate and I work on. And this department is dedicated really to designing and installing and coordinating solar energy systems for buildings that are currently under construction, whether that's a gut renovation on a townhouse or a new building in Queens that is a giant commercial office building or something like that. This allows us to really coordinate with architects, and it's specifically helpful for coordinating with projects that are passive house. We want to really make sure that what we're installing is not inhibiting these design principles that are so important to this type of project. So here are our specialties: alterations, renovations, new buildings, anything that is changing, anything that's being built that has construction involved, that's handled by our specific department, specialty projects, that Kate and I both work in. One thing that is important to note, a lot of these new buildings or existing buildings that are undergoing renovation need some compliances. So we found that solar is becoming more and more necessary in New York City, and to pass through some DOB compliances, you'll actually need solar on some specific building types. Local Law 92 and 94, mainly for major alterations to existing roofs or new buildings, they require 100% of that roof to have a sustainable roofing zone, whether that's a green roof or solar. And so we can help advise on how to make sure that your building complies with those laws. 97 is about limits on carbon emissions for buildings. So, with passive house design, that is alleviated a bit, which is great. And then any new buildings receiving a new certificate of occupancy are required to have solar on one of those roofs.
And worth chiming in, this local law 9294 came out in 2019 with New York City's COB, kind of slow rolled out the interpretation of the law between, plan examiners, kind of also depends on the borough sometimes. But with that said, there's a chance you might not see that come up even until sign off. So the goal is to get us on board as soon as possible to avoid any kind of scrambles when you're at the end and looking for TCO or C of O.
We have some standard offerings when it comes to solar energy systems that we install. I'll go into these a little bit on the next slide, but just to give you a broad overview, we have a tilt rack, which is our lower surface mounted system. And then we have two canopy style systems, an A-frame canopy and a post truss. And let's take a look at what those look like. So a typical tilt rack system, this is our lower mounted system. We're using aluminum framing underneath the equipment, and then the solar panels go on top. This is perfect for a landmark property, for a brownstone that wants limited visibility. And this is usually a really cost efficient option if you have a nice sized rooftop. If we need to build up higher, if there are obstructions on the roof, we typically go with a canopy. This allows us to exist above the vertical fire department clearance of 9 feet. And it's great if you have, a ton of dunnage on the roof that is difficult to work around. And then here's our post truss. This is our little sleeker designed system. Depends on the type of roof that we're attaching to that determine which type of canopy we can do or what type of system we can build. So always important to coordinate roof construction with solar implementation.
It's worth noting too, the post truss can often be used for carports or yard canopies. Zoning has kind of changed somewhat in the last few years in New York City to allow for that. So we're seeing more and more post truss systems in yards.
And we're still developing canopies as well. Different styles of systems that we can use. So yeah, carports are sort of the next frontier, it seems.
Mm-hmm.
Very important to talk about how we're attaching to these rooftops. Kate, do you want to talk a little bit about?
Yeah, happy to jump in. Yeah, so this being a passive house meeting and crew, important to know that attachments are going to be a little trickier to collaborate on. So we love to work with you guys and figure out a way to avoid any penetrations to the roof. With that said, we still have to lag onto something. So these are kind of our standard roof joist solutions, but later on in the presentation, we'll talk about some customized solutions for passive homes. Starting with the tilt rack, that lower structure that Sean showed, we have a standard bracket style attachment. Kind of distributes the load out by attaching to the decking and then distributing point loading out to the rafters from there. For the canopies, we have a T-track aluminum extrusion that hits 2 to 3 rafters ideally. And then for the post truss, that's kind of a more custom engineered base plate. Usually utilized for concrete roofs, or if sometimes we'll attach to dunnage or other structures on the roof. Again, that requires a bit more engineering on our end, but it can be done. Next slide.
One important piece of solar implementation here is how we're connecting to an existing electrical account. Depending on the type of building, the type of area, typically with residential solar in New York City, it's impossible to get a battery all the way through permitting at this point. Seems possible in the future, but as of now, we're mostly tying into existing electrical accounts, which means we're tying directly into the grid with Con Ed. So we're tying in, we're using NEM1 or net metering, which sends out the kilowatt hours to the grid. Con Ed counts those kilowatt hours and delivers credits back to a client as a reduction on their owed cost for their future bill. Typically with a property that we're looking at, we're trying to determine an electrical usage for that property. For a new building, obviously we're using some estimations on existing properties in New York City, some averages. So we're trying to tailor our systems to that existing electrical usage or a potential future electrical use so that we're sizing our systems correctly. Usually for a very large building, we're trying to fill up the entire roof space to offset as much cost as possible with the utility. For a client in an existing brownstone or townhouse or even pitched roof home, if they've lived in it before, we can utilize a recent bill and come up with an electrical usage estimate to figure out what they'll use in the future and base our system size on that. Typically, with the type of power we're producing, we want to offset as much as we can. That's the best return financially for a client. So if we're producing 100% of a bill, that's our ideal. We try and stay away from working on these systems as percentages, as most of the value comes from the dollar amount and not from how much electricity they're projected to use. So typically, the more money we can save a client, the better it is for them and better return they'll have for the long term. Kate, do you want to talk a little bit about our design strategy with zoning?
Yeah. So for any proposal early on, we're taking into account a lot of the, AHJ codes. That includes zoning allowances. And, I know we have a lot of folks from other states here. We're talking strictly 5 boroughs, New York City. Zoning, back in 2023, City of Yes was like a massive sustainable green energy movement in the city that brought a lot of great openings for things like wind, batteries, solar. Essentially just raising the blanket permitted obstruction envelope height to 15 feet above all rooftops. So a bit agnostic of zoning districts, we have that allowance now, which is great, especially for canopies. The NEC code, that's another element here, super important for us, especially when we go down the line for sign off. We have an in-person DOB electrical inspection. So oftentimes we're working in tandem with your team, electricians. We want to make sure the grounding, all of the electrical equipment is compliant. So we're looking at this from the very beginning. Super ideal to have electrical schematics from the start when we're looking at a new project. And then lastly, kind of the bulk of how we design spatially on a roof is looking at the fire code. A bit stringent, as we all might know. There's clearances, there's a 6x6 front landing zone, maintaining that contiguous path from front to back, side to side. We're essentially mapping that out before we even map out where the solar goes. So that's another reason why the canopy is great. It alleviates some of that Tetris puzzle strategy there. But also important to note, DOB is the one interpreting the fire code. It's not necessarily the FDNY that's looking at our plans, unless we file for something like a variance. So yeah, these 3 elements, super important. And we are also permitting these projects in-house. So we'll be filing on behalf of the client, and we'll often need your backgrounds to get that going. So now the flip side, if your team has solar in mind and we're not on board yet, there's a bunch of things that we'll need from you down the road. Like I mentioned with the attachment, structural feasibility. We need something to hold up this structure. Our systems are engineered, but we'll also need to make sure that the roof that you're working on is capable as well. So sometimes there's some cross-pollination of engineers from our team and then yours. Just looking at wood rafters for the brownstone kind of world, and then nowadays more and more concrete roofs. In the passive house realm, that also involves, the insulation and making sure again that we're not penetrating or we're providing that thermal blocking there. Electrical scope, kind of mentioned it before, but just we need somewhere to tie the solar in. The easiest solution is to have a breaker that we can easily put at the very bottom of the existing service panel. But there are other ways that we can do this, but that's ideal. So early on, if we can jam with your electrician on that, that helps the project down the road. And then this comes up oftentimes mid-construction, a new vent pops up. Maybe you move the condenser. That could totally thwart the solar design. So communication is key, but also being mindful of what we would need spatially, because even one vent can totally mess up our fire path, or it might be in place of where our attachments go. So just want to keep that communication open there.
Yeah, an important piece to just piggyback off what Kate just said. Having solar in mind at the beginning of design and development and throughout the project is always useful, so that the optimal solar energy system exists from the design phase all the way through and can be installed at the end.
So as I mentioned, we are permitting this in-house. We have expediters, we have an applicant of record, our engineer. So especially for landmark buildings, we're handling all of that. We're handling a photo study, showing sightlines from the street. All of these filings will directly handle. If you guys as architects ever want to include solar, we need to be in coordination there. You could show it on your plans, but it's better to just say filed separately. Plan examiners at the DOB tend to get stuck on things, so we like to keep things separate. With landmark buildings, oftentimes we'll have to use a tilt rack structure due to visibility reasons. It's pretty tricky to get a canopy approved, could lead to a public hearing, which might be a waste of time. So we try to just propose tilt racks for landmark structures. And then FDNY, as I mentioned, there are instances where there are non-compliant roof elements, so we'd have to file a variance with the FDNY. And then DOB will file a permit for solar as well as for the electrical portion of our work. And those two get tied together up until the sign off of the entire project. And then once we're on board, this is the rough timeline. I will spare reading each bullet point, but the best first step is to have a kickoff call with the team. If a GC is on board, even better to have a walkthrough. It's great to be on board during design development. Typically, we tend to get called on once the permitting phase demo has started. So that's what I typically see as a PM. So we'll do a walkthrough, we'll map out the conduit route. That's usually the first step, is to get that dedicated conduit from the electrical area and then internally route it up to the roof. So those are usually the two first steps. And then in tandem, we'll go through the permitting, the drafting, all of the permitting for the electrical portion as well. And then honestly, depending on the stage of the project, it really takes about 2 to 3 months to get the actual permits. And then the install itself can take 1 to 2 days, depending on the scope. So all in all, it's, once we're on board and things are ready for us, it could be, within 1 quarter to get everything built.
And then, we our business, we want to get paid for our systems. And so typically we take a deposit up front. That gets us on board. That starts the coordination that allows us to make sure that what we've designed is possible. The next payment usually comes once the equipment is deployed and on the roof. So the longer time we get to coordinate, usually that's the best value for a client. And then also that gives us more time to make sure that we're not inhibiting on any of these principles. We don't want to mess with the building envelope. We want to make sure that the insulation is intact, things like that. So once we have our deposit, our retainer, we'll continue to coordinate until the day of the installation, and then the client will owe the final amount, and should receive their very rich tax incentives on solar after that. If we do need to additionally service a project like this, we need to come out for any extra designs. Of course, we can add those in. We can make sure we have time to do that and the ability to. There are some tax incentives currently available for someone going solar, whether that's a commercial system or a residential system. This NYSERDA rebate at the top is dwindling. For these types of projects that are take a year, 2 years, it's unlikely that the NYSERDA rebate will still be around. But for projects that are finishing up, that could have solar in the next couple of months, there's a chance that the NYSERDA rebate will stick around, and that's a nice solid chunk of cash from New York State that gets paid to a solar contractor. So we would take that rebate that we get back and take that cost out of the owed cost for the client. Once we get sign off on our permits, once the DOB sees that there's solar on the property, they'll reduce the property taxes for 4 years. That can be up to 30% of the system's cost. So for 4 years, the client or the property owner will see a reduction on their property taxes, which can be a nice chunk as a reduction there. And then income tax. There's 2 income tax credits currently. There's a federal income tax credit and a state income tax credit. The state income tax credit is only available if it's a primary residence. There's a commercial tax credit that we can talk about if you do have a commercial customer. But the federal income tax credit is quite rich right now. And I'd say the earlier things get signed up, probably the better we have a chance of claiming that. But all in all, it should be about 70-ish% of a project cost that will come back to the client, leaving them with having paid only about 30% of the total cost. Kate, do you want to talk about our inverters?
Yeah, so what we have here are 2 examples of what's called an inverter, which is kind of functioning here as the brains of the solar system. DC energy is collected from the sun and then transferred over to AC energy, which matches the grid here in New York City with the use of these mechanisms here. Also, they contain the cell modem that can communicate the Wi-Fi, or sorry, the data from the production of the system. So that's how the fun part with solar is you get the app and you can kind of see what your system is doing in real time. It'll, show graphs or, layouts of the arrays themselves. So usually once we set this up, people are pretty excited to see what solar could do. And then after a year's worth, you can kind of see what seasons, typically spring, summer, produce the most and what that looks like production-wise against your build usage from Con Ed. So on the left, that's what's shown there is a micro inverter. These are 1-to-1 for each panel on the roof. So they're mounted right underneath, they're strung together. If one panel is being shaded, it's not going to knock out the rest of the system. They're not tied together necessarily in that way. And each microinverter is communicating per that panel's production. On the right is a string inverter, which is basically a bit larger of a box there, typically housed in the basement near the rest of the electrical equipment. It can go either way, though. We can mount them on roofs as well. There's usually a strategy there for that. And that is a series string connection. So all of the panels are strung and communicating through that inverter there. So there's different tactics. The microinverters are our most common product here. And the app for Enphase is pretty user-friendly. On the right, we're showing an SMA string inverter, but we also propose inverters from a company called SolarEdge.
And usually
Sean,
our string inverters are used for like our bigger projects, right?
Yeah.
The commercial projects that contain, hundreds of solar panels will typically string those together with a string inverter. And then our typical residential projects, smaller systems, microinverters make a lot more sense there.
All right, so what we're about to go through are some typical plan layouts that we might receive from architects on the left, and then how we might interpret the fire code to help optimize and max out the system size. A common myth is that the fire path clearance has to be front to back, side to side in an orthogonal way. Oftentimes it's interpreted as just front to back, but we've found ways to kind of work with the fire code and basically hug any obstruction on the roof, like skylights, vents, and make that fire path work for the system. So you'll see on the left, if you're thinking in terms of just clear area, you might not be able to fit that many panels. But on the right example, we've found a way to basically have in the dark maroon sections, keep that close to those obstructions. Another thing to mention is that there is a bit of a loophole in the fire code where any existing roof element on a roof that's narrower than 25 feet wide, we can reduce that fire path to 4 feet wide from the 6 feet requirement. So because when we come into play, everything is existing on the roof, even if it might be new for you, we'll use that FAQ exception from the FDNY to try our best to just squeeze in one more panel if we can.
Definitely important to send us your plans so that we can do that.
On this page, this is a interpretation of the pitched roof code, which is a bit different from flat roofs. In this case, we only need 3 feet of clearance on either side of the ridge there. So a bit more free to add solar. Don't need to connect the fire path necessarily unless there might be a portion of flat roof, which we've seen some pushback from DOB on that. But for a traditional pitched roof, this is usually what we need to show for compliance. Here is a great example of where we collaborated, but just not quite in time. If you see right there, there's a vent right in the space that could be perfectly set for another panel. And, on the far left, that was the initial idea for the design. A pretty cool cantilever solution here that we figured out by beefing up the supportive rail, we could cantilever further out, which creates this nice kind of overhang. But yeah, kind of one of those, wish we were in a month earlier to stop that vent from being in our place. And then this is another example of our canopy in dealing with a rear extension. So essentially dealing with 2 different roof assemblies. We have a more traditional sistered roof in the existing building towards the north of the plan there. And then with the rear extension, an entirely C-joist roof assembly. We had our engineer take a look at it and then figured out that what we needed was just a bit of a beefier connection. So we proposed using pressure treated roof or wood blocking, and then basically building up that curb to meet the roof finish with the insulation underneath it. So we have that solution only at the rear extension, and then our typical T-track lag solution at the existing building. This is an example of a project that we built in Bed-Stuy. It's a pretty cool situation where we were kind of thought of from the beginning. This is a project by Paul Castrucci Architects. He basically designed the pitch of this roof to be due south, which is optimal for solar. So in this design and layout, and keeping us in mind, we were able to collaborate and essentially almost cover the entire roof with solar. So you'll see we kind of keep that contiguous fire path going from the front clearances all the way through to the back. And then if you go to the next slide, you'll see the final version there. So pretty fun to see this come to life, as you all can experience.
Yeah, just a great example of, collaboration in action from the start.
Yeah. And then another scenario here. This was a collaboration with Baxton Gui Architects. This was a split system, which means we sent half of the solar to a commercial account and then the other half to the residents. So kind of figuring out what the usage needs are. A bit difficult here because we were filing as pitched roof code, but the architect was filing with flat roof code. So we kept some clearances in mind for their final sign off to make sure that they were compliant and we were compliant as well. This here is a post and truss canopy that we proposed in Long Island City. Sean, do you mind speaking a bit about this one?
Yeah, absolutely.
Yeah, thanks.
This is our post and truss. This was possible because we knew this new construction would be on, a concrete roof that allowed us to put our attachments down and have footings properly fitted to the structure. And then it allowed us to build, a huge solar array on this property in line with the architect's vision. For an open roof space. And I'll go to the next page here. We can see the finished design. Nice and flush, powder coated black, matches the building's aesthetic nicely. And then here are just some photos of our systems installed. This is our A-frame canopy. This is a block of landmarked properties that have solar on them. You can see this is using our tilt rack structure to avoid any visibility from the street. This is our larger ballast style array. This is usually reserved for much bigger properties. And this would allow us to not penetrate the roof surface. So worth noting that a ballast is weighed down by usually concrete blocks. So depending on the structural stability of the rooftop, we might be able to deploy something that doesn't have any penetrations to the roof, but does, weigh a decent amount. And then our passive house custom solutions that Kate, you can.
Yeah. So something we've been doing quite often to try and mitigate the thermal blocking to prevent any leakage is coordinating with some kind of brand. We've seen Armatherm. Some variation here of thermal blocking helps us because like I mentioned, we have to lag in somewhere. Unless it's a large rooftop for ballast, like Sean just mentioned, there's going to be a decent amount of penetration. So in coordinating with this type of product, this has helped us figure out solutions. On the right, there's some details that we've drawn in collaboration with ZH Architects to help get our canopy mounted to our typical ideal base plate, which has a through bolt solution to the parapet wall there. A, avoiding penetrating the actual roof surface, and B, maintaining that, that thermal blocking there to keep that insulation. So this took a bit of work. It's not something that we have as a standard engineering option, but we're so willing to collaborate and figure that out because we know that's such an important principle. It's just one of those things that we're going to have to attach somewhere, especially for a canopy structure. So just showing here that solution.
We're going to jump over to Q&A, everyone. It's awesome to see that you all were really, really thinking hard about this. So what we're going to do is Jose and I are going to kind of ping pong back and forth with introducing these questions. We would love it if you wanted to unmute yourself and go ahead and ask your own question. If not, or if you're maybe not in the meeting anymore, then we will ask it for you. So we'll give you a couple seconds there to find that mute button. If your question's already been asked and we call on you, just let us know. So I will start us off here. Andrew Fowler, are you online? Would you like to answer? Or probably you don't want to answer your own question. Would you like to ask your question? Well, it looks like he might not be here anymore. I'll ask it. Does Brooklyn SolarWorks do annual operations and inspections?
We do not. We could, but typically our systems do not need any maintenance, any inspections, because data is being reported via the internet to our office and to to the client. It's very rare that we ever have to do any maintenance. Of course, we are happy to do that, but typically these systems can live on rooftops for over 30 years and never need any maintaining.
Nice. Thank you, Sean. But so I was actually going to ask about maintenance after we finish the Q&A if we had time. So good. Thank you for expanding on that. Next would be Patrick Caraher, and it looks like he has left the call. So I'll ask his question. How has IRA chaos and current expected tariff affected BSW's costs, pricing, and business case? I guess we'll know more today too about that question.
Sean, do you want to take that one? Or?
Sure. So obviously there's some chaos out there. We're finding that the administration is not hyper focused on solar right now. So we're expecting the federal incentives to stick around. A lot of the IRA is tied to manufacturing, and so attempts at dismantling the IRA could negatively affect a lot of industries, and a lot of U.S. based manufacturing operations. So it seems relatively rare that we'll see any direct reductions in the federal income tax credit. Obviously, we'll have to wait and see as it goes forward. But from what we've heard so far, we have a year or 2 years potentially of the federal income tax credit sticking around as is. And obviously, the sooner we can get clients signed up and on board and these systems installed, the more likely they'll be able to claim those incentives.
I love that we're all just kind of collectively confused sometimes about the IRA stuff. The chaos is a good descriptor for that. All right, Eric Zeiss, I think you might be here still. Would you like to ask your question, or would you like me to do so? I'm gonna give you a little. There we go.
So I sort of had 3 questions that involve solar on the facade of the building. One is whether you've considered building integrated PV for any of your designs. The second, related to that, is integrating that with solar thermal for hot water heating. And I guess a third version of that, which is at this point further down in the list, is whether you've looked into the possibility of using shade structures, i.e. a PV shade over windows to also increase the amount of solar power generation and decrease solar gain in the summer on south-facing windows.
Kate, you want to take that?
Yeah. Thanks, Eric. Yeah, I think it's a bit tricky for the engineering aspect, and I think this can touch all 3 examples here, or maybe everything but the solar thermal question. But for vertical building integrated PV, we've certainly been asked. It's not incredibly high of a demand, which is why it's not really a standard product of ours. It does involve way more engineering to understand, the vertical, like wall assembly of the building. It's not a never, but it's something that, we'd have to research thoroughly. We'd need like complete collaboration. And, it can be done. It's just not something we offer as a standard solution for solar. And frankly, it's not as efficient from my understanding of solar compared to having a tilt rack or a canopy. And that has to do more so with, directing it completely due south, but at a certain degree, usually 30 degrees is most optimal for production and efficiency. As for solar thermal, I, I can't say for sure. Again, a bit more of a rare solution that we've seen. I'm not entirely sure how DOB allows that. I think it was more common maybe 10, 15 years ago. Sean, feel free to chime in or correct me, but it's not something we're seeing very often paired up with solar.
Yeah, I feel like solar thermal was very popular in the past. Yeah, maybe 10, 15 years ago. Um, in places like, Florida, where it's typically sunny all year round. I think in a place like New York City, where uh, there's not much roof space, it usually makes more sense to put up like electricity generating solar that could, uh, intentionally affect a hot water heater if hot water was electrified. Um, so, the ability for a PV panel to distribute electricity to a toaster or to your hot water heater seems from our point of view, and from the direction of clients, that it makes more sense to do something like that. And then solar thermal does take up a lot of space, so um, depends on what the priorities of the building are.
And to also circle back to the PV shading, similar to the vertical application of PV, kind of depends on you know, the the area around the windows. I also think it might be dependent on whether or not it can play nicely with certain inverters that we showed before. So we choose our equipment. We have go-tos of what we prefer for both the modules themselves and the inverters. So yeah, rare applications like PV shading and vertical wall application, we'd need to do a lot more research to see how it plays with the electrical equipment.
Okay, thank you for the context there. Can go to Shannon. Oh, she's gone from the meeting, so I'll ask her question. How standard is rack sizing, panel sizing across the industry?
Pretty standard. Panel sizing hasn't. I've been here for 5 years. It hasn't strayed too far from what we're using now. Usually, panels are about 4 feet by 6 feet, and that's sort of industry standard for residential projects. For larger commercial projects, we can usually fit a larger panel. Um, but typically, yeah, they end up around the same size of 4 feet by 6 feet. Kate, I don't know if you have any extra
No, that's
things there.
totally right. Yeah.
Yeah.
The commercial panels are larger and have more cells, which, each panel is made up of a bunch of small cells, usually 66 or 72. So yeah, that's about right.
A follow-up there. When you mean commercial, you mean, let's say for a multifamily residential building, would that be the 4 by 6, or you would use the bigger ones because it's a
Sorry,
bigger volume and more
yeah,
power?
I sort of meant like a more horizontal building than like a more vertical building. So like for a multifamily brownstone, we'd use the 4 by 6. For like 100 unit, building, we'd probably use the 72 cell.
So yeah, so it's a function of the area available, not really the use, so
Exactly.
to speak.
Yeah.
Okay, thank you.
Yeah, great clarification there too. All righty, Dale N at Tacoma, Washington. Would you like to ask your question?
Sure, I might as well add in here. Thank you for what you're doing. I'm amazed it's working so well. You have a lot of obstacles. I only asked about turbines, and you've already had solar thermal underneath your panels. And yes, you were mostly correct, but there's a lot of history there, and thermal is coming back. There's more countries outside of the United States. It's a big world. So if you looked at turbines, I mean, you do have wind, and you actually have big storms in New York City too.
We have not looked at wind. I think for homes in New York City, these brownstones would have limited available space. Small wind turbines do not produce enough electricity for it to make sense. From my understanding, again, we are just a solar company. That's our main focus. So I can't speak to Brooklyn Wind Works, which might be out there in the future. But as of now, we've found that solar generating electricity seems to be the most straightforward way to implement clean energy solutions into existing brownstones in New York City. And again, we are dedicated to just New York City, so we are limited in that way.
Well, that's a big area. It's bigger than several countries.
Sure.
And I think you're doing great for what your obstacles are with your power company and your location. Yeah, I could add a lot, but let's go on to the next questions. I'm impressed with some of the questions. I hope you keep gaining on knowledge. Actually, solar is getting old. After 3 years of knowing what recordings are, I would consider looking at maintenance or recording history, because after 3 years, you get bored looking at who cares what your thing's doing. It's there. I'm into 15 and 20 years out.
Sounds good.
It
Thanks,
is
Dale.
funny. It's funny to go to other countries and they're like, they've had solar for decades and we're kind of behind in that respect. So yeah, I feel you, Dale.
You're muted, Dale. Still muted. You have to press the mute, the space bar, maybe.
Okay, you click me. You can't probably click me off. She got bored. All right, keep studying and keep working on it. It's a great venture. As I said, I'm 15, 20 years out on mine and my sister's. So there's a lot to do out there.
Thanks, Dale. Appreciate it.
Yeah, thanks, Dale. Good insight there. Next up is Rick. I actually don't know if he's still in the call.
Yep,
Maybe
I'm
he
still
is.
here. How you doing?
Great. Go ahead.
So my question was about bifacial panels, vertical installation, not on the wall, but in a farm or on a rooftop. I know that conformal applications that you've shown today would be more applicable to the general city structure, but suburban and urban can take advantage of the improved efficiency of the bifacial vertical farm. So just wondering if you're looking at that at all.
Yeah, we've installed bifacial panels before. Typically, we would not install them vertical. They would be flat on just our previous installations. We found that with I've never delved into the vertical type, but we found with the horizontal installs, they tend to not produce as much as their single side counterparts. That might just be because the roof surface isn't bouncing as much light as, maybe the sky would or something like that. But that's what we've found, and maybe it was just the panels that were available to us at the time, the technology that was available.
The study I'm referring to is you vertically in place them, and you're getting east and west sun across there. There's several, you just Google it. There's probably as many, as there's people on this site studies. So, and they found that was more was producing more electricity per panel face than just doing your 30-degree orientation to the south. So just, obviously the downside is you've got to structure them so they can take winds, etc. They're using them on farms where they can use land in between and other applications. So where you need real estate, they're very good for.
Yeah, definitely. If we end up finding a big piece of land in New York City that we can install, maybe Central Park, we can look into that.
Staten Island.
Yeah, I bet you
Yeah.
could figure it out on a rooftop, on a good size.
Oh yeah, on a big rooftop, sure.
Anyway, all right, thanks.
Thanks for the question, Rick.
Rick, I saw that comment and I had to Google the double-sided ones, and they're really cool looking. Um, Anyway, we have up next Margaret. Margaret Legg, would you like to answer? My goodness, I keep saying that. Would you like to ask your question so that it can get answered?
Yes, I would. So I'm a carpenter, and I've noticed that on job sites, the prints don't always match up to reality. So how well a job can go is dependent on like how knowledgeable the workers are and how well they work with like the architects and everyone on site. So I was wondering, where are you getting your qualified workers from to do this work because it's new? Are you training them yourselves, or are you like getting workers from specific companies? How are you finding the workers to do this work?
Kate, do you want to take that one?
Yeah. Thanks for your question, Margaret. We have a great install crew team, comprised of roof workers, many with your background of carpentry and construction, generally in New York City. And then we have a team of electricians. So I can't really speak to our, hiring sources, but we definitely go through training, OSHA, safety, all of that is mandatory here at BSW, especially site safety for taller buildings. It's a big deal, and we take it seriously. And we have a construction manager named Dan for our division, and he's just the best. And he and I often go through walkthroughs together, and he's marking up the track locations. I'll talk to the owner, the architect, and yeah, we work in tandem, and I can safely say they're extremely knowledgeable. Hope that answers your question. I can't tell you exactly where they're coming from, but I know they definitely have construction experience here in New York.
Yeah, I might chime in here and just reiterate, like we have really amazing team leaders for our construction teams. And that knowledge sort of trickles down and everyone is trained from those leaders, and a lot of those leaders have innovated and created these types of installations themselves. So yeah, we're definitely trying to educate as much as possible. It's definitely new business here for New York City.
All right, thank you guys. Next up, it's Jay Stearns.
Hi, thanks for the presentation. It's great. I'm curious, thinking through possible projects, the connection to landmarks and this idea. Part of my question was answered in your presentation, but do you do kind of hybrid where you do the lower tilt racks and then can do a higher canopy, thereby allowing, and also the question about the equipment under the canopy and the vents. I was trying to figure out from your drawings if the canopy then allows for that issue of venting and AC to exist underneath it. And my second small question is, in terms of blackout situations, are there add-ons or that allow the house to operate in under those conditions?
Great, I can take this one. For landmarks, yes, that is exactly our strategy, is to put a lower mounted structure towards the front. Landmarks cares most about that primary facade visibility. We are allowed about a foot of visibility of the structure itself. So it's not that it has to be invisible. We often try to keep it that way, especially if there's like a tall cornice. And then if we're allowed to place a canopy at the very rear, that would be allowed if there's no through block visibility. So there are situations where we can put a canopy at the rear and then it's not visible from the primary street facade. Yes, the canopy is pretty much designed to elevate far above any venting. We can also place tilt rack structures over vents. They just can't really be, flush against each other. We definitely try to coordinate with the contractor to make sure there's some breathing room. I think the trickiest vent to deal with, frankly, is like a gooseneck, because it not only is vertical, but projects out horizontally as well. And that's just more of maneuvering the structure itself. But yeah, canopies are probably the best solution to mitigate the venting and they can live together. I think that answers your question there, but happy to move on to the blackout question. The way things are going with New York City, we are grid tied. So unfortunately, if there's a blackout, the solar is out as well. I think Sean mentioned we are trying to figure out collectively in New York City how to make batteries easily permittable. We kind of have some clues. You know, it's an option to file for a battery permit, but there are many jurisdictions beyond the Department of Buildings. There's a third-party group that is reviewing the battery application. Super concerned about just adjacencies of, you know, for the concern of combustibility, fire. So until we get clear-cut rules, we're just not offering that currently. So unfortunately for now, blackouts where, you know, the solar is out with everything. So
Makes sense. Thank
yeah.
you.
All righty, it looks like our next question is from Tyler. Tyler Harmon Townsend, would you like to unmute and ask your question?
Yes, I'd love to. First off, thanks for a great presentation, you guys. This is fascinating. I'm kind of piggybacking on that last question. I'm also very curious about battery storage and the future of that. I got curious when you were talking about the fact that you're still doing a lot of both types of inverters, microinverters and string. I'm curious if you're getting any requests from client or if it's a design consideration to go with string inverters so that you're future-proofed for a battery installation later on.
I think at this point, clients are still not super aware, so we're not getting a ton of specific questions about inverter types or module types. I will say I think the types of batteries that are out there now, and correct me if I'm wrong, Kate, but microinverters could still work with like a Simplify battery, for example, like a battery pack that's retro
Yeah, I think so.
compatible
Yeah.
with an existing system. So I think at the stage of the technology now, it's pretty compatible. We're pretty adaptable. Depends on how far away the solar installation is from like the battery installation. That would really determine some difficulties with technology.
Yeah, and to piggyback on that, there's like different methods of pairing a battery with existing solar. There's DC coupled, there's AC coupled, all of that to say, if anything, we would advise clients that want a future battery. We'll often say like get an additional conduit line in your building. It's usually the best way to future proof because we'll know that we'll need to run additional wires, whether that battery lives on the roof or their yard or wherever DOB will allow us to place it. So yeah, the conduit is usually the best way to future proof.
Got you. Thank you. I also had a second very easy question. I was just curious what product you guys are using typically for ballasted installations.
So these days we're using Iron Ridge, which is pretty simple. Like there's just one base common bracket that allows to attach to like both PV modules. I'm like miming it as though I'm building it for you. So yeah, Iron Ridge BX is usually our preferred ballast these days.
Awesome. Thanks so much.
No worries.
All right. Up next, it's Douglas Massey.
Hello, great presentation. Do you guys ever have a goal as far as kWh per square foot of living area per year when you're speccing a system?
That's a great question. Typically, no. We have a goal for these typical projects is usually just to build as much as we can. That's our typical situation. For existing properties that aren't under construction or renovation, the electrical use here in New York City can vary, you know, extremely. And you know, somebody who's in a house, you know, can be using 4,000 kilowatt hours for the whole building. Someone next door could be using 20,000. So for those existing buildings, we're really trying to analyze individual bills and not determine, electrical production based on like space or size of the property. Everyone uses electricity differently, and we try and match that with existing properties. But for these new constructions, typically it makes the most sense to build as much as we can. The roof space for townhomes are limited. Even for big, warehouse buildings, they might be using a ton of electricity. Filling up the entire roof space might only account for 25% of what they're using.
Okay, and then I had one other question. Have you ever done any systems with movable panels with solar trackers or tiltable in order to increase efficiency?
We have not, under my understanding. Typically, what we've found for New York City, like climate and then sort of our maintenance policies and things, the more moving parts, the harder it is to ensure that a system will exist as is for many, many years. Ideally, we're never coming out there and maintaining a system. And then that's better for a client as well. But we're trying our best to angle the panels so that they are optimized for like, where we are on the globe, to make sure that they get the most sun for for a fixed position. I don't know if you have any more thoughts on that, Kate.
Yeah, no, I think you said it best. Probably worth also adding, after showing our layouts, typical New York City flat roofs have a lot of obstructions. So we're usually working with a set area to begin with. Any parts of the city with substantial real estate to have a movable tracking module or array, we have yet to really like encounter. Similar to the vertical application, it's something we've definitely been asked about, but we would need to research further, I think, to offer it.
Very good. Thank you.
All right, I am going to ask a question for HC. Do you all have a ballpark cost or like a range for a solar project that you wouldn't mind sharing with us? From, either a small residential project to maybe a larger office building?
Sure, yeah. Typical brownstone townhouses. That initial project cost might be in the range of 45 to 50,000 bucks for these projects. For a canopy, it might be 55 to 60K. And then for large office building projects, depending on the size, it can go from 100K to 500K. Really depends on what size we're working with, what kind of installation, how many, solar modules we're installing on the roof, what type of equipment we're using, etc.
Okay, let me see what the next questions are. Let me just see the time as well. Kim, do you think you have time for a few more questions?
We have 2 minutes, so let's see how far we can get.
All right, so then next time it's going to be, well, this time it's going to be Stephen Graham. And I think he is on the call.
Yes, thank you very much. 3 questions, slightly unrelated, but I'll still bundle them all together anyway. First point is I'm based in the UK, and we've had a few issues with Chinese manufactured solar panels being in contravention of like companies' modern slavery policies. So it'd be interesting to hear if you've had any issues with that. And then also in terms of panel cleaning, if you would recommend sort of regular cleaning, and if so, via what means, if it's just wash down or something else. And then also it'd be good if you could touch on payback periods in terms of number of years as just sort of typical payback times.
Yeah, thanks, Stephen. So yes, we currently do not use Chinese manufactured solar panels. A lot to do with that reason, and then a decent amount to do with just the quality of that of the equipment coming out of China is not as high as the quality coming out of, let's say, Korea, South Korea, where we're seeing our panels manufactured, and then a lot of assembly is happening in the U.S. And we're getting incentives to have U.S. manufactured equipment here. So that's the first part. I think the second question about panel cleaning, I think it depends on your climate. So for New York City, we don't recommend it just because we get enough rain. We tilt the panels enough that the wind, the rain, snow, everything sort of washes off any buildup of dust. But I assume in a place like the UK, you're getting enough rain where you probably don't need serious cleaning or like scheduled cleaning. But I think spraying it off with water might just do the trick.
Yeah, we to chime in on that, because I get asked this a lot as well for projects that have been around for a few years. We recommend not to use any kind of cleaners because it could damage the cells themselves. Water is fine, and even so, we would say like something gentle. Yeah, it gets asked, but generally, like Sean mentioned, the rain will do that job.
Awesome.
And then to
Oops,
touch on the last bit of your question, which was payback period. We're seeing paybacks sort of range around like the 5-year, even earlier than that, depending on the size of the system. Obviously, if we're working on a building that has a very small amount of space, the payback period can go up. But we're trying to build things that have 4-year payback periods.
That's great. Thank you very much.
That's smart. That's awesome. Thanks, guys. We've had such an awesome conversation today. Really quite the dialogue. And Yasan, I see your question. It's a great question. It's also a whole can of worms. So I invite you to maybe connect with our speakers today via LinkedIn or email, and I'm sure they can really flush out quite the answer for you.
Yes, Sarah, I'm wondering if maybe we can put up our last slide again that has our contact information to share with
That would
everyone.
be awesome. And we'll also definitely send this out to folks. And just a reminder, this presentation will be available on our YouTube channel. I think Kim just threw the link in there in a couple days. So thanks, everyone. Enjoy the rest of your days.